This film shows a fuel valve overhaul for a Burmeister & Wain K84 type diesel engine. The principles demonstrated also apply to all other fuel valves of B&W design. However, it is recommended that in all cases the instruction manual be thoroughly studied before the overhaul is commenced. Fuel valve overhauls should be carried out in a special locality where there is no risk of contamination by swarf or grit. Start by laying out the tools and checking that everything is in order, especially the working surfaces of the grinding plate and the grinding ring, etc. The fuel valve overhaul should be carried out in a special clamping jig which is supplied with the engine. A bench vise should not be employed. Take out the adjusting screw together with the feeler pin, thrust spindle and spring. Unscrew the nuts for the slip filter and remove the filter by means of the extractor tool, which is positioned by screwing it into the threaded hole provided in the filter body. Raise the valve into the vertical position and clean the nozzle with a wire brush. Before undoing the sleeve nut, any carbon deposits between the nut and the nozzle should be removed with a milling tool. Lower the valve into the horizontal position and lock it in the clamping jig. Before loosening the sleeve nut, the clamping jig thrust spindle must be tightened against the nozzle. Otherwise, the dowel pins in the nozzle or the housing might be shorn when the sleeve nut is loosened. The sleeve nut should be loosened with an impact spanner, not with a torque spanner. Remove the sleeve nut, nozzle, spindle guide assembly and rubber ring. Take out and scrap the dowel pins in the housing and nozzle. Remember to place a protective plate under the pliers in order not to damage the mating surfaces, which must provide a perfect oil-tight seal. The atomizer hole cleaning drills, fixtures and test pin are supplied in a separate plastic case. During cleaning of the center hole and atomizer holes, the nozzle tip should point upwards to allow any dirt to fall out. Examine the atomizing holes by means of a magnifying glass. They must be circular and keen-edged. Having ensured that the hole geometry is in order, the dimensions are checked by means of the test pin. If the pin is able to enter one or more of the atomizing holes, the nozzle must be scrapped. The sealing face of the nozzle against the spindle guide is to be lapped on the grinding plate using emery powder number 7O and some solvent. Apply steady movement to and fro and do not turn the nozzle. Note that the nozzle is shifted to the dry part of the plate during the last few strokes. After the lapping, there must be no marks or scores in the sealing surface, apart from the very fine lines that result from the lapping. Flush the nozzle through with a solvent and blow it dry with compressed air. Always fit new dowel pins. The old ones must not be used again. Check the spindle and spindle guide. If the spindle is corroded, or if the width of the conical seat is more than approximately 0.5 millimeters, the pair must be exchanged. These parts cannot be reconditioned on board. The lift of the valve spindle is checked by first measuring the distance between the sealing faces of the housing and the upper edge of the stop ring. In this case, it is 13.4 millimeters. Then, secondly, the distance is measured between the top of the spindle and the sealing face of the spindle guide. Here it is 12 millimeters. The difference indicates the lift of the spindle, which in this case is 1.4 millimeters. For all KEF type engines, the maximum permissible value is 1.3 millimeters, and consequently the stop ring must be taken out and a new ring adapted. This job should normally not be carried out on board, but instead the housing should be sent either to Burmeister & Wain or to one of our authorized repair shops. If damage marks or scores are found on any of the four sealing surfaces of the housing, the spindle guide and housing must be ground to match. Before grinding, fill the apertures with Vaseline. This ensures that no grinding paste will enter them during grinding. Fit the guide ring on the housing. Using carborundum number 500, grind the spindle guide and housing to match. After the grinding, wipe the parts carefully clean with a clean cloth and check the sealing surfaces. Lap the spindle guide in the same way as the nozzle, the last few strokes being on the dry part of the grinding plate. After the lapping, there must be no marks or scores in the sealing surface, apart from the very fine lines from the lapping process. Flush the spindle guide through with solvent and blow it dry with compressed air. Then, clean the bore of the spindle guide with a clean cloth on a small wooden stick. Wipe the spindle dry and dip it in acid-free oil before inserting it in the spindle guide. Clean the housing thoroughly with kerosene and blow through with compressed air. Note the direction for blowing. Always blow from the valve head towards the nozzle end. Once again, remember to fit completely new dowel pins. Also fit a new rubber sealing ring between the housing and the sleeve nuts. Then, with the spindle in place, fit the spindle guide on the housing and thereafter place the nozzle on the spindle guide. The threads and pressure faces are smeared with molybdenum disulfide. Mount the sleeve nut and tighten it lightly by hand. Lower the valve into the horizontal position in the clamping jig and lock it. Remember to tighten the clamping jig thrust spindle against the nozzle tip. This is in order to avoid shearing the dowel pins, which would result in misaligned atomizer jet directions in the engine cylinder. The tightening torque for the sleeve nut is indicated in the data book. For the K84 type, it is 40 kilopond meters. This torque spanner will give a jolt and a click when the correct tightening torque is reached. Dismantle the slit filter in a vise fitted with protective jaws. Unscrew the sleeve nuts. Remove the sealing ring, spring guide and spring and take out the non-return valve disc. Take out the vent screw and remove the thrust ring. If there are damage marks or scores in the valve seat, it should be ground with carborundum number 500 on the grinding mandrel supplied. If there are marks in the vent screw seating, this can be refaced with a pin drill fitted in an ordinary hand drilling machine. After refacing the seat, the filter housing should be cleaned with kerosene and blown dry with compressed air. The disc of the non-return valve should not be reconditioned by grinding. If it is defective, it must be scrapped and a new one fitted. A convenient method of replacing the valve disc in the housing is, for instance, to stick it on the end of a pencil by using a small blob of Vaseline. Position the spring, spring guide, thrust ring, sealing ring and sleeve nuts and tighten the sleeve nut with the pin spanner. When the filter has been assembled, it should be tested in the jig supplied. Clamp the filter in the testing jig. Fit the pressure pipe on the filter inlet and check the opening pressure of the non-return valve. The opening pressure is stated in the data sheet. For the K84 engine, it is about 13 kilopond per square centimetre. When the opening pressure has been checked, the pressure pipe should be removed from the filter and the testing jig with the filter should be rotated half a turn in the vise. Then the pressure pipe should be connected to the testing jig. The non-return valve and the filter sealing ring should remain oil tight at a pressure of 100 kilopond per square centimetre. This can be checked by ensuring that no oil leaks out at the filter inlet. Smear the filter with molybdenum disulfide and insert it in the housing. To ensure even tightening, the filter stud nuts should be tightened in 3 distinct stages with a torque spanner. The first stage is performed with a torque spanner set at a moment of 3 kilopond meters. Before each tightening operation, the knurled disc of the spanner should be retracted and rotated a quarter of a revolution. When the correct tightening torque has been reached, the knurled disc will be released. The second tightening stage is carried out at 6 kilopond meters. Ensure that all 3 nuts are correctly tightened at each stage. The third and final tightening is to be made at 10 kilopond meters. Insert the spring guide, spring, thrust spindle and adjusting screw in the housing. Mount the protective guard and connect the test pump. Open the vent screw and pump until bubble-free oil flows out of the return oil outlet hole of the housing. Close the vent screw and pump again. The oil jets from the spray holes should then pass through the holes of the control screen. This indicates that the oil jet directions will be correct in the engine cylinder. Adjust the valve to the opening pressure stated in the testbed table. For the K84 type, it is 250 kiloponds per square centimetre. When the opening pressure has been attained, tighten the adjusting screw lock nuts. Wipe the nozzle tip dry with a cloth and hold the pump pressure for a couple of minutes at 200 kiloponds per square centimetre. If the nozzle shows signs of sweating or dribbling, the valve must be dismantled and the fault traced. Before checking the atomization, the pressure gauge valve must be closed in order to protect the gauge. Check that the cooling oil ducts are free from congestion by blowing through with compressed air. In order to enable the valve to enter the sleeve of the cylinder cover, trim off the outside projecting edges of the rubber sealing ring between the sleeve nut and the housing. Any damage on the contact face of the sleeve nut where it bears against the cylinder cover should be ground away by means of the grinding ring and carborundum number 120. When the overhaul has been completed, fit protective caps on all pipe connections and on the nozzle end, and push the rubber sealing ring into position on the valve shank. The reconditioned valve is now ready for remounting in the cylinder cover or for storage as a spare.